before humanity built its first city, before the pyramids, before the dinosaurs walked the earth. The universe had already existed for billions of years. Stars were born, galaxies collided, entire worlds appeared and disappeared. For almost 14 billion years, the universe has been waiting. Today, astronomers estimate that the observable universe contains more than 2 trillion galaxies. Inside those galaxies, there may be hundreds of sextillions of stars, more stars than grains of sand on every beach on Earth. Around many of those stars, planets quietly orbit in the darkness. Some are frozen, some are burning worlds of fire, and some may look astonishingly similar to our own Earth. If even a tiny fraction of those worlds develop life, then intelligent civilizations should be everywhere. Some millions of years older than humanity, some far more advanced than anything we can imagine. And yet, after decades of searching, after listening to the stars, after scanning the skies with the most powerful telescopes ever built, humanity has found nothing. No voices, no signals, no visitors, only silence. If the universe is filled with life, why has no one answered? Why has no one come? Why is the universe so silent? One simple question, asked by a physicist over lunch, would become one of the greatest scientific mysteries in history. Where is everybody? The Fermi Paradox. We call this place home. A small blue planet orbiting an ordinary star. For thousands of years, this was the entire universe we knew. Every civilization, every empire, every human who has ever lived existed here, on this tiny world. But Earth is only one planet, orbiting one star. Our solar system contains 8 planets, hundreds of moons, millions of asteroids, and countless icy worlds, stretching billions of kilometers into the darkness. Yet, it is only our neighborhood. Then, our sun becomes almost invisible, because it is only one star, among nearly 400 billion others. Together, they form the Milky Way, a galaxy so enormous that light itself needs 100,000 years to cross it. And yet, the Milky Way is not alone. It is only one galaxy, inside a family, called the local group. More than 50 galaxies travel through space together, bound by gravity, for billions of years. Then, our entire galactic neighborhood shrinks into a tiny point because the local group is only one small cluster. Inside the universe, containing more than 2 trillion galaxies, each one filled with stars, each star possibly surrounded by planets. Now ask yourself, if Earth is the only planet where life has ever appeared, then all of this would exist for absolutely no one else. An entire universe, empty, silent, waiting. Could that really be true? Every point of light you see in the night sky is a star. Most of those stars are not unique. They are suns, just like our own. For centuries, we wondered whether those distant stars might have planets. Today, we no longer wonder. We know they do. In 1992, astronomers confirmed the first planets orbiting another star. Since then, the number has exploded. Today, we know of thousands of exoplanets, and new worlds are discovered almost every month. Many are unlike anything in our solar system. Others look surprisingly familiar. Wherever scientists search for life, they begin with one simple ingredient: water. On Earth, every known form of life depends on it. Over the past decades, astronomers have found water almost everywhere they look. Frozen inside comets, hidden beneath icy moons, floating as vapor inside distant planetary atmospheres. Water is not the only ingredient. Scientists have also discovered organic molecules drifting through enormous clouds of gas and dust between the stars. These molecules are not alive, but they are the building blocks from which life can eventually emerge. Not every planet can support liquid water. Some orbit too close to their star and become scorching hot. Others are so distant that their oceans freeze solid. But between those extremes lies a narrow region astronomers call the habitable zone, a place where temperatures may allow liquid water to exist for billions of years. In 1961, astronomer Frank Drake asked a remarkable question. If we know how many stars exist, how many of those stars have planets? And how many planets could support life? Could we estimate how many civilizations might exist in our galaxy? The exact answer remains unknown, but the question itself changed the search forever. Every year, the evidence grows stronger. More planets, more water, more potential homes for life. And yet, after decades of searching, the universe remains silent. The more likely life becomes, the more mysterious that silence appears. By the middle of the 20th century, the mystery had become impossible to ignore. The universe was ancient. The Milky Way contained billions of stars, and if planets were common, then some civilizations could have appeared millions, perhaps even billions, of years before us. In 1950, physicist Enrico Fermi was discussing extraterrestrial life with his colleagues when he asked a remarkably simple question: where is everybody? Think about what that question means. Our own technological civilization has existed for only a tiny fraction of cosmic history. And yet, in just a few centuries, humanity has gone from crossing oceans under sail to launching machines beyond Earth. We have surrounded our planet with satellites, landed robotic explorers on other worlds, and sent spacecraft farther into space than any human has ever traveled. Consider how quickly this happened. Less than a century after the first powered airplane flight, machines built on Earth were already exploring the surfaces of other planets. Today, robotic explorers photograph distant worlds, analyze rocks, study atmospheres, and search for evidence that environments beyond Earth may once have supported life. And technologically speaking, humanity is still at the very beginning. Now imagine another civilization that did not begin a few thousand years before us, but a million years before us. What could a million-year technological head start produce? Even without impossible faster-than-light travel, a civilization capable of moving between nearby stars could slowly expand outward. One star system becomes two become 10 become thousands. Given enough time, its presence could spread across enormous regions of the galaxy. And time is exactly what the universe has had. The Milky Way is more than 13 billion years old. Earth formed much later. That leaves an enormous window in which other intelligent species could theoretically have appeared before humanity. A civilization only a tiny fraction older than ours on a cosmic scale could still be millions of years ahead technologically. If such civilizations exist, some of them should have had more than enough time to leave evidence behind. So humanity began to listen. Giant radio telescopes turned toward the stars, searching for signals that nature should not produce. Scientists looked for repeating patterns, narrow radio transmissions, and other possible signs of technology. Instead of waiting for visitors to arrive, we began asking whether distant civilizations might already be broadcasting their existence across the galaxy. And we did more than listen. We placed powerful observatories above Earth's atmosphere. Modern space telescopes can study light from distant worlds and examine the chemistry of planetary atmospheres many light years away. For the first time in human history, we are beginning to search not only for planets, but for clues about what may exist on them. And yet, after decades of searching, the result remains the same. No verified message has arrived. No unmistakable technological signal has been confirmed. No spacecraft from another civilization has appeared. We have discovered thousands of worlds, listened to the sky, and sent our machines deep into the solar system. But we still have no confirmed evidence that another technological civilization exists anywhere beyond Earth. And that is what makes Fermi's question so powerful. If intelligent civilizations are common, some should be far older than humanity. If some are far older, at least a few should have developed technologies beyond anything we possess today. And if even one civilization had begun spreading between the stars millions of years ago, why can't we see any evidence of it? Somewhere between a universe that appears capable of producing life and a sky that gives us no confirmed answer lies the Fermi Paradox. And perhaps the most frightening possibility is not that we are alone. Perhaps civilizations do appear. Perhaps something simply prevents most of them from surviving long enough to meet each other. Perhaps the silence of the universe is trying to tell us something. Maybe planets capable of supporting life are common. Maybe life itself begins again and again across the galaxy. And yet, somewhere between the first living cell and a civilization capable of crossing the stars, something may happen, a barrier that almost no civilization manages to cross. Scientists and philosophers have given this possibility a disturbing name: the Great Filter. The filter could be behind us. Perhaps the first step is already almost impossible. On Earth, simple life appeared relatively early in the planet's history, but we still do not know how difficult that beginning really was. Chemistry somehow crossed the boundary and became biology. Molecules began to organize, reproduce, and evolve. It happened here. but we have no idea whether the same transformation happens icily on other worlds, or whether Earth won a cosmic lottery with almost impossible odds. Or perhaps simple life is common, but complex life is extraordinarily rare. For billions of years, Earth was inhabited almost entirely by microscopic organisms. Complex multicellular life arrived much later. Intelligence came later still. The path from a simple cell to a creature capable of looking at the stars was not a straight line. It depended on countless evolutionary accidents, environmental changes, and mass extinctions. Perhaps most living planets never get this far. And even complex life does not guarantee intelligence. Earth has produced millions of species, yet only one built radio telescopes, spacecraft, and computers. Dinosaurs dominated the planet for more than 160 million years without developing a technological civilization. Intelligence may not be evolution's inevitable destination. It may be an extraordinary exception. If the great filter lies somewhere in our distant past, that would be extraordinary news for humanity. It would mean that we have already passed one of the most difficult barriers in the universe. We survived the impossible step. But there is another possibility. One that is far more disturbing. What if the great filter is not behind us? What if it is still ahead? Every technological civilization may eventually reach a dangerous stage. Its ability to change the world becomes greater than its ability to control the consequences. Powerful technologies can provide energy, medicine, and knowledge. But those same advances can also create weapons, destabilize environments, or produce risks that earlier civilizations never faced. The more powerful a civilization becomes, the more carefully it may need to manage its own power. Imagine that this pattern has happened before. Somewhere in the Milky Way, a civilization could have reached the same threshold thousands or millions of years ago. It may have built cities, studied the stars, and wondered whether it was alone. And then, something happened. Today, its planet might still orbit its star exactly as before. Oceans gone, atmosphere changed, technology silent. With enough time, almost every visible trace of that civilization could disappear. This would offer one possible answer to the Fermi Paradox. The galaxy may not be empty because intelligent life never appears. It may be quiet because technological civilizations do not remain visible for very long. Perhaps they reach a certain level of development and then disappear. If that is true, the silence around us is no longer simply an absence of evidence. It becomes a warning. But there is one question we cannot answer. Is the great filter behind us or ahead of us? Every dead planet we discover may eventually help us understand. If we find simple life everywhere but no advanced civilizations, the implications could be unsettling. But if even simple life turns out to be extraordinarily rare, then perhaps humanity has already crossed the hardest barrier of all. For now, we simply do not know. We are one young technological civilization on one small planet, trying to understand a silent galaxy. And somewhere in that silence may be the answer to whether our future lasts for centuries or millions of years. But extinction is not the only explanation for the silence. There is another possibility. Perhaps advanced civilizations are out there right now. Perhaps some have survived for thousands, even millions of years. They may have explored their planetary systems, developed technologies far beyond our own, and discovered that the galaxy is not empty. And perhaps that discovery taught them one simple rule: stay quiet. This idea is often called the dark forest hypothesis. It is not a proven scientific theory. It is a thought experiment about what might happen when civilizations, separated by enormous distances, discover one another, but cannot know each other's intentions. Imagine walking through a dark forest at night. You know that someone else may be hiding among the trees. You do not know who they are. You do not know what they want. And most importantly, you cannot know what they may become in the future. In that situation, announcing your position may not feel like an act of friendship. It may feel like a risk. The problem is distance. Even light has a speed limit. A message sent to a civilization 1,000 light years away would take 1,000 years to arrive. If they answered immediately, another 1,000 years would pass before we heard the reply. Two civilizations could begin a conversation and wait centuries or millennia between sentences. During that time, governments could disappear, cultures could change, and technologies could advance beyond recognition. The civilization that receives your message may be very different from the one that eventually answers it. Humanity has not always been quiet. For more than a century, Earth has been leaking radio transmissions into space. Radar systems, television broadcasts, and powerful communication signals have expanded outward from our planet at the speed of light. Most become extraordinarily weak across interstellar distances, and detecting them would be difficult. But we have also deliberately transmitted powerful messages toward the stars. In cosmic terms, humanity has already begun to whisper into the darkness. In 1974, astronomers used the enormous Arecibo radio telescope in Puerto Rico to transmit a powerful message toward the globular star cluster. Messier Yisan, the transmission contained encoded information about humanity, DNA, our solar system, and the telescope itself. It was largely a demonstration of what the technology could do, not a realistic attempt to begin a conversation. The cluster is roughly 25,000 light-years away. Even if someone received the message and answered immediately, their reply would not reach Earth for tens of thousands of years. Now imagine a civilization far older than ours, reaching the same conclusion. It may decide that broadcasting its existence offers little benefit and an unknown amount of risk. Its cities could minimize detectable emissions. Its communications might use technologies we cannot recognize. Its probes could operate quietly across its own planetary system. From Earth, such a civilization might appear indistinguishable from an empty star system. The silence we observe would not mean nobody is there. It could mean that the civilizations capable of surviving for a very long time learned how not to be noticed. This raises a debate that is no longer purely theoretical. Should humanity actively send powerful messages toward potentially habitable worlds? Or should we listen without announcing ourselves? Some researchers argue that any civilization capable of reaching Earth would probably already have ways to detect signs of our planet and perhaps our technology. Others argue that deliberately transmitting powerful, targeted messages creates a risk we cannot calculate. There is no global agreement, because humanity has never faced a decision quite like this before. Perhaps the Great Silence is exactly what it appears to be: an empty galaxy. Perhaps intelligent civilizations are extraordinarily rare. Perhaps the Great Filter removes most of them before they can spread among the stars. But there is another possibility. Somewhere beyond the light of our sun, civilizations may be listening just as we are, watching, waiting, saying nothing. If the universe really is a dark forest, then silence may not be evidence that we are alone. Silence may be evidence that someone has learned to survive. And that leaves humanity with a question we have never had to answer before. In a universe whose intentions we cannot know, how loudly should we announce that we are here? The silence of the universe seems simple. We look into space, and nobody answers. But silence does not necessarily mean emptiness. Another civilization could exist without producing anything our instruments recognize. The real problem may not be that there is nothing to find. The problem may be that we do not yet know what we are looking for. One strange possibility is called the zoo hypothesis. Imagine a civilization millions of years older than humanity. It might have discovered Earth long before we invented radio, but instead of contacting us, it could simply observe from a distance, allowing our civilization to develop naturally, much as humans sometimes observe wildlife without interfering. When we imagine extraterrestrial technology, we usually imagine versions of our own: radio transmitters, spacecraft, cities, and machines. But those technologies are products of human history. An intelligence that developed under completely different conditions might create machines that look nothing like anything humanity has ever built. A sufficiently advanced technology might not look artificial at first. To us, it could resemble unusual dust around a star or an unexplained change in brightness. Astronomers might observe it, measure it, and place it inside a scientific database without ever realizing that intelligence had anything to do with it. There is another possibility. What if someone reached our solar system long before humans existed? Earth is about 4.5 billion years old. Our technological civilization occupies only a microscopic fraction of that history. A visitor could have arrived millions of years ago, when there was nobody here capable of understanding what had happened. Millions of years can erase almost everything. Mountains rise and disappear. Continents move. Ocean floors are recycled. Erosion destroys exposed structures. Even the remains of our own civilization would become increasingly difficult to recognize in the distant geological future. If something visited Earth in deep time, obvious evidence may no longer exist. We also assume that an advanced civilization must remain on a planet, but that may only describe an early stage of technological life. Over thousands or millions of years, intelligence could spread into space, become increasingly dependent on machines, or survive in environments where biological bodies are unnecessary. There is also the problem of time. Humanity has searched the sky with modern technology for only a tiny moment in cosmic history. Another civilization might have flourished millions of years ago and disappeared long before humans evolved. Two intelligent species can exist in the same galaxy and still never overlap in time. And that may be the most unsettling possibility. The universe may not be empty at all. We may simply be searching for civilizations that resemble ourselves. Perhaps evidence of intelligence is already somewhere in the data. We have seen it. We have measured it. We just do not yet know what it means. So far, we have asked why the universe appears silent. But there is another question. What exactly should we be looking for? Scientists do not search only for life. They can also search for technosignatures, possible evidence that technology has changed a planet, a star system, or the space around it in ways nature alone may struggle to explain. One possibility is artificial light. From far enough away, Earth becomes a tiny point, but its night side contains something unusual. Cities. A sufficiently powerful future telescope might detect similar patterns on another world. Light concentrated where natural illumination should not exist could become one clue that a distant planet is not entirely natural. Technology could also leave chemical fingerprints. An industrial civilization may alter the atmosphere of its planet. Certain artificial pollutants or unusual combinations of gases could potentially be detected across interstellar distances. We would not see factories or inhabitants. We might discover civilization first, as a strange pattern hidden inside a spectrum of light. A civilization might also communicate with light. Extremely powerful lasers could produce brief optical flashes brighter than their host star at specific wavelengths. Such a signal would not need to remain visible for long. A telescope on Earth might receive only a short pulse, perhaps lasting seconds, that had traveled across space for centuries. Even a civilization trying to remain quiet may face a basic problem. Energy produces heat. Computers, machines, and enormous habitats must eventually release waste heat into space. Astronomers can search for unusual infrared radiation around distant stars. We may never see the machines themselves. We might see only the energy they cannot completely hide. At the extreme end are megastructures. A civilization far older than ours might build on scales measured not in kilometers, but in millions of kilometers. Vast structures could partially block the light of a star in unusual patterns. We have never confirmed such an object, but astronomy allows us to ask whether engineering could someday become visible across the galaxy. There is another technosignature that could be much closer. Machines. A civilization capable of interstellar travel might send autonomous probes instead of biological explorers. Given enough time, such machines could travel between stars, observe planetary systems, and perhaps remain operational long after the civilization that created them had disappeared. The difficult part is deciding what counts as evidence. Nature produces strange signals too. Stars pulse, atmospheres change, thus can create unusual patterns of light. A genuine technosignature would need to survive repeated observation and every plausible natural explanation. The first evidence of another civilization may begin not with a photograph, but with an anomaly in data. Perhaps discovery will not begin with a spacecraft arriving above Earth. It may begin with one strange spectrum, one repeating flash, or one distant world whose light does not behave as expected. Then the observation is repeated. Other telescopes confirm it. Natural explanations disappear one by one, and eventually, humanity is left with an extraordinary possibility. We are not alone. After everything we have discovered, one fact remains unchanged. We still have no confirmed evidence of another technological civilization. Perhaps intelligent life is extraordinarily rare. Perhaps others are too distant, too different, or already gone. Or perhaps the universe is not silent at all. Perhaps we simply have not learned how to listen. And that may be the most important part of the Fermi Paradox. The silence of the cosmos is not an answer. It is a question, one that pushes us to look farther, build better instruments, and understand our own place in the universe. Somewhere beyond the next star, the answer may already exist. Until we find it, we keep looking. If you enjoyed this journey into the unknown, subscribe to Hidden Files and join us as we explore the mysteries science has yet to explain. New stories are coming, and you won't want to miss them.